So we want to try to figure out what type of function we can use to represent the circumstances that we see here. So we have a rock that's being tossed off of a cliff, and we're keeping track of its vertical height in feet above the water or the ground where it's tossed. So again, the first thing we've got to do is we've got to check to see that the t or the x variable, whatever that first variable is following a linear pattern where we're adding or subtracting the same thing every time. And indeed we are. We're adding 0.5 every time. So it's not 1, it's not 2 like we've seen in previous examples, but plus 0.5. But as long as it's consistent, we're in good shape. So now we've got to look at the height, the position, the height of the object as time goes by. So that's our second variable. And so again, we're going to subtract here. So 276 minus 280, so we're going to get negative 4. If we subtract here, we're going to get negative 12. 244 minus 264 is negative 20. So clearly we're not seeing a consistent difference in this first set of differences. If we subtract one more time, it's negative 28. We could keep on going, but this is good enough for us for here. So it's not a linear function, so now we have to do a second round of subtraction. So we're going to subtract the differences. So here's our first difference. Those were not constant, so now we're checking the second. So negative 12 minus negative 4, negative 12 plus 4 is going to give us negative 8. Negative 20 minus 12, so negative 20 minus negative 12 becomes plus 12, so that also is negative 8. And then here one more time, we again confirm that we're going to get negative 8. Negative 28 minus negative 20 is indeed negative 8. So our second difference is constant, and so that tells us that we have a quadratic, and so the equation that's going to work for us is y equals ax squared plus bx plus c, and now our job is to find what the values of a, b, and c are. So we've got to pick points from our table of values to start plugging them in to build a system of equations. And once again, we've gotten lucky that we've got an input value of 0 with an output value, which is going to allow us to find what c is pretty easily, because we're going to go 280 in place of y equals, and then I'm going to plug in 0 in place of x. So really it's t is the variable here. So it's going to be a times 0 squared plus b times 0 plus c. So these two parts are going to go away, and we get c equals 280. So we know one of these three constants for our equation. We now have to figure out the other two. So we can just use the next 2 points if we wanted to, but I'd rather use these that have integer values rather than the ones that have decimals. That way I can kind of work in my head rather than having to push buttons on a calculator. Really, we can use any of the points that we want, but I'm going to opt for those two. So I'm going to start off with this one right here. So I'm going to plug in 264 in place of y, or in place of h, equals, and so then that's going to be a times 1 squared plus b times 1 plus c. But again, we already established that c is 280, so I might as well go ahead and just plug that in right now. And then I'm going to jump to this point right here. So in place of h or y, I'm going to plug in 216 equals, and now x or t is 2, so it's going to be a times 2 squared plus b times 2, and then plus again that c value of 280. So now we've got our system of two equations and two variables, since we already solved for that third one. So now let's just clean up these equations a little bit to get them in a little bit more user-friendly format. So I'm going to subtract 280 from both sides. So 264 minus 280, it's going to be negative 16. So I'm going to get negative 16 equals, then I've got 1 squared times a. Well, 1 squared is just 1, so 1 times a is just a. And then plus b times 1, so just plus b. And then again, we've already taken care of that 280 there. Then we're going to do the same thing in the next one. I'm going to subtract 280 from both sides. So I've got 216 minus 280, so that's going to give me negative 64. We can use a calculator to help us out, or we can just do that in our head. So we got negative 64, and then again, I've got 2 squared times a, 2 squared is 4, so I've got 4a, and then I've got this b times 2, so plus 2b. So I've got my two equations cleaned up a little bit in a little more user-friendly format. And so I want to eliminate one of these two variables. So I'm going to go ahead and work on the b. Well, if I want the b's to disappear, I've got to multiply that top equation by 2, so I get a match there. So I'm going to get negative 32, because I have to multiply everything by 2, and then 2 times a, and then plus 2 times b. And then the bottom one I'm just going to copy as is. So negative 64 equals 4a plus 2b. And so now to get rid of the b's, I'm going to subtract these two equations. So if we do that, if we subtract, so here when we're subtracting we have to be cautious about our positive and negative signs. So we have negative 32 minus a negative 64. So that's going to be negative 32 plus 64 when we're all done. So negative 32 plus 64 gives us a positive 32. And the rest of the way is pretty straightforward. 2a minus 4a is going to give us negative 2a. And then again, we've subtracted these so that the b's would disappear. So our last step here to solve for a is to divide both sides by negative 2. And so now I've got 32 divided by negative 2 is negative 16. So we've got a is negative 16. So we've got 2 of our 3 unknowns. We already had c from early on. We've got a now. And so our last thing we've got to do is solve for b. And I'm going to go right here. Before we multiply that equation by 2, that's about as easy as it's going to get. So I've got negative 16 equals a we just got was negative 16 plus b. Well, hopefully it's pretty obvious that for that to work, b must be 0. If we add 16 to both sides, we're going to get b equals 0. So that, along with the other two variables we solved for, gives us our equation. So we've got y, or I'll actually use the variables that we see here. We're going to have h, the height of the object, is equal to a, so negative 16 t squared, since we're keeping track of time, so we'll use that variable instead of x. And then there's no bx term, since b turned out to equal 0, and then plus 280. And so this equation format is quite common for a falling object. So the idea is you've got this negative 16, which is representative of gravity, the effect of gravity on the object, and then the t squared, the time squared, shows that as time goes by, the object starts getting faster and faster. And then right here, this 280, the whatever number is in that position, will always be the height of the object above the ground when it starts to fall. So for a falling object, this is generally the format of the equation that we'll see, and this will pop up again in our future as well.